We're measuring stuff constantly, right? A scoop of coffee, the distance on our morning jog, it just feels automatic. But what if I told you there's a whole other level to getting it perfectly right? It's part art, part science, and today we're going to pull back the curtain on that secret. Seriously, have you ever followed a recipe to the letter, measured everything exactly like it said, and it still turned out, well, just wrong? Something went sideways, but you can't figure out what. Well, the problem usually isn't what you're measuring, it's how you're measuring. And mastering that how changes everything. Okay, so to get it right, we need to get two ideas straight that sound the same but are totally different: accuracy and precision. Think of it like throwing darts. Accuracy is hitting the bullseye, you're correct. Precision is about consistency. It's about hitting the exact same spot over and over and over, even if that spot isn't the bullseye. To really nail anything, you absolutely need both. And then there's the big one, the piece of the puzzle that is absolutely critical: units. I mean, if I just say the number 32 to you, what does that even mean? 32 degrees? 32 feet? 32 poodles? A number tells you how much, but the unit tells you of what. Without it, you've just got a random number floating in space. So how do we put all this together, accuracy, precision, and units, to become measurement masters? Well, it turns out there's a simple set of rules. It's kind of like a secret handshake that scientists use to get it right every single time, and you're about to learn it. And look, this isn't about needing some fancy, expensive gear. Nope, it's all about technique. It's one single powerful idea that unlocks the hidden potential in any measuring tool you've got, whether it's a measuring cup from your kitchen or some high-tech gadget in a lab. You ready for this? Here it is. The secret sauce. The golden rule of measurement is this: always estimate one digit beyond the smallest marking on your instrument. This is the game changer. You're not just reading the lines that are printed there. You're actually interpreting the empty space between the lines. That's where the magic happens. That's the key to true precision. All right, enough talk. Let's actually put this rule to the test. We're going to start with two things we measure all the time: length and volume. Okay, first things first. Before you measure anything, get into this habit. Look at your tool. I mean, really look at it. Find the smallest little division it has. On this ruler, the big numbers are centimeters, and all of those tiny marks in between are millimeters. So the smallest marked off bit is 1/10 of a centimeter, or 0.1 centimeter. Okay, so we've got our smallest mark. Now, what was that rule again? So if you look close, that gray bar goes past the 7.8 centimeter mark, but it's not quite at 7.9. It looks like it's, about halfway between them. This is where we do our estimate. That last digit is our best, most educated guess. Let's call it a 5. So our final, super precise measurement isn't just 7.8, it's 7.85 centimeters. See the difference? Now, the same rule works for liquids, but there's one little trick. You ever notice how water kind of curves up at the edges of a glass? That curve has a name. It's called the meniscus. And here's the pro tip. You always read the measurement from the very bottom of that curve. You got to get your eye right level with it and read from the bottom of the dip. And speaking of pro tips, you have to know this. Not all glassware is for measuring. You see the lines on the side of a beaker or a flask? Think of those as suggestions. They're really just for holding and mixing stuff. If you need a real precise measurement, you have to grab a tool that's designed for it, like a graduated cylinder. It's all about using the right tool for the job. Okay, you've got length and volume down. Let's level up. We're going to tackle mass and temperature next. And the best part? The core rule is exactly the same. It's just the tools that change. With a modern electronic scale, it's almost like a cheat code. The machine is so smart it does the estimating for you. So what's your job? It's simple. You write down every single digit it shows you. That very last digit on the end, that's the one the machine has estimated. So here, you'd write down exactly 173.865 grams. Easy, right? All right, pop quiz time. Let's use our rule on this thermometer. Step 1. What's the smallest mark division? Let's see. The numbered lines go up by 10, and those little dashes, they're not single degrees. Each tiny mark is actually 2 degrees. So our smallest mark is 2 degrees Celsius. Got it? Okay, smallest mark is 2 degrees. You know what's next? Time for the golden rule. So since the marks are every 2 degrees, our one digit beyond means we're going to estimate to the nearest 1 degree. Makes sense, right? We look at the red line.
It's past 30, past 32, and it looks like it's sitting right on 34. Our final reading, 34 degrees Celsius. See? The rule works for every single tool.
And hey, once you've got that super precise number, switching scales is a piece of cake. A simple formula like these is all it takes to go from Celsius to Fahrenheit, or the other way around. And there you have it. Just like that. You've got the whole toolkit. You know the fundamental rules that separate just, guessing from true scientific precision. So let's do a quick recap. This is your new measurement checklist. Number 1, units. Always, always, always. Number 2, know your tool. Find that smallest little mark. Number 3, the golden rule. Estimate 1 digit beyond that mark. Number 4, for digital scales, write it all down. And number 5, with liquids, read from the bottom of the meniscus. That's it. That's the whole secret. And look, this stuff isn't just for a science lab. This is for baking a cake that actually turns out perfect. This is for nailing that DIY project you've been putting off. It's about understanding the world around you with a whole new level of clarity. So, the only question is, now that you're in on the secret, what's the first thing you're going to measure?